Hello, everyone. My name is Yongyi Liu, and on behalf of my collaborators, I'm presenting the work Scalable Spatial-Temporal Top-K Community Interactions Query. With the popularity of location-based services, an increasing number of users are posting data through social media platforms such as Facebook, Instagram, and Twitter. This kind of data has been explored and analyzed to serve applications in different domains such as business, science, health, and politics. Suppose a sociologist wants to study the behavior of a specific community, like what are the posts that are interested to teenagers in the US over the last week. This kind of study on a specific community is very important in the following categories. Political scientists could draft proposals according to the targeted group's focus. Sociologists could analyze the social hot topics among different communities. Marketers could advertise the commercials more specifically according to the group's preference. Formally, our problem is defined as given a virtual community, a time interval, an optional query point and an optional spatial range, an optional set of keywords, we find the top K post that the virtual community has interacted the most during the time interval and within the spatial range and contain any of the keywords. The interactions could be like, reply, click, and so on. An example of such query is to find the top 10 tweets that the teenager community interacts the most over the last week in Los Angeles area. This figure shows the indexing framework. The incoming posts are first of all indexed into the master data index, so we can always retrieve the detailed content of a specific post. Most importantly, the community index indexes the interactions between the community user and the post. The query processor makes use of the indexing components and return the top K results to the user. To the best of our knowledge, none of the existing work can solve the query on a community scale. This figure shows our community index. Since the query is issued on a community level, we index the community as a whole instead of indexing each individual's interaction. So we have a hash table where the key is the ID of the tweet and the value is the number of interactions that the community users have interacted with that post. We also have an inverted list that stores all the keywords that have appeared in the post. And under each of the keywords in the inverted list, we store a similar hash structure. The length of the temporal slice is defined by the user. In this example, we set the length to 1 day. We then propose two algorithms to efficiently process the query, a baseline algorithm and a fast algorithm. The baseline algorithm is naive. It simply aggregates the interaction from the different time slices covered by the query and then sort and return the top K results to the user. The fast algorithm is inspired by the Fadge's TA algorithm and prunes the unnecessary search space. The fast algorithm incrementally builds the top K results by using the priority queue. The details of the algorithms are presented in the paper. Thank you.